Hi, I'm Justin Uberti, Head of Streaming Technology at Clubhouse, and today I'm going to give some thoughts on what I'm calling RTC3. Now, if you came here expecting this to be about blockchains, you might be disappointed. There's some interesting potential overlap between RTC and Web3, but that's for a different day. What I want to talk about today is what's happened over the past 20 years in RTC and what directions things might take in the future. So I like to think about the past of RTC in a couple different generations. First generation, 2003. There were RTC apps before, but when things really took off was with the launch of Skype. Suddenly you could make a reliable phone call from your desktop, and then in 2005, Apple starts adding video cameras to its MacBooks, and for the first time now you can reliably video chat with somebody from your computer. And between Skype and all these other applications on the desktop, this was a pretty big deal. Now, there were some apps that supported multi-way calling, but it was typically just through a mesh setup, which meant that quality was kind of rudimentary. But by the end of the decade, desktop one-to-one calling was pretty mature. Then Apple released FaceTime for iPhone in 2010, and that opened the door to a much larger audience of potential video chat users. And around the same time, we started the WebRTC effort, which served as the first high-quality, freely available RTC platform, which then enabled many other applications to add RTC capabilities into their apps. Finally, during this time, a lot of work went into building out reliable systems for online video meetings. And while adoption didn't really go through the roof just yet, the key building blocks, cloud SFUs, simulcast, and layer coding, were also developed and tuned out over this time. So then the third generation, COVID happened. Pretty much all online products saw enormous growth, and online meetings in particular exploded as teams suddenly had to figure out how to work together when they weren't in the same space. I thought it was pretty incredible that all the big conferencing apps were able to hang on and scale their services when they encountered 50x growth just in a matter of weeks. One of the amazing things that led to this type of growth was that these meetings could all be joined just by sharing a URL. And this ability to join by URL allowed people to add meetings to calendars, send them around in chat, and that type of easy sharing behavior sort of required a cloud architecture, a cloud SFU architecture, so there's a common location that everyone could code and connect to when they joined the meeting. So yes, a huge step forward in terms of making online meetings work for everyone, but it turns out that not every social interaction really is a meeting. And when you're trying to use kind of a meeting tool sometimes to do other forms of social interaction, it can feel kind of stilted. Socializing on a Zoom call, virtual happy hours, I think we've all experienced some of this, and it still kind of leaves a bit to be desired. So fortunately, though, the post-COVID world saw a huge explosion in different types of RTC apps. And given the ubiquity of APIs like WebRTC and several platform as a service providers that offer compelling RTC cloud services, startups are suddenly able to build differentiated RTC experiences in weeks rather than years. It was really pretty incredible to see, these new apps breaking new ground, whether it was the interesting conversations that are happening on Clubhouse, or bringing a virtual office to life on Gather, or streaming AAA games over a WebRTC connection as on Stadia or GeForce Now. In many ways, RTC technology is now ubiquitous and reliable, and developers can focus their energy on building unique experiences. There are all sorts of different things taking shape, but the main category that I sort of like to put them all into is what I call real-time social apps. These apps are group-based, where you can kind of easily connect with your online community using voice and video just by clicking on a link. Now, sometimes these apps offer something in addition to the audio and video experience, allowing for more than just talk. Playing a game together, watching a movie together, working on a project together. The key thing is this notion of you're sort of interacting in real time and you're doing it together. And I think this is a pretty interesting direction because it's creating this whole new category of differentiated apps. Now, this new class of apps makes us reevaluate some of the technology that we're using and where we actually think innovation is needed. And I'll talk about that a little more now. So first, kind of go deep on kind of, what we might want to do around audio. We wanted to make 100-person video meetings work. And so in order to do that in the RTC 2 days, we had to make enormous investments in video technology, new video codecs, improved bandwidth estimation, work on rate matching. And while on the audio side, the Opus codec was a huge step forward, it often seemed that the stack was much more mature and there wasn't as much to do. Now, when you have 100-person meetings, suddenly shortcomings in the audio stack become much more pronounced. Audio in online meetings often feels kind of flat. And if you try to perform music, it's really kind of like a subpar experience. And I think we all have our own frustrations with the mute button. But adversity kind of creates room for innovation. And I'll talk about some of the exploration I've done at Clubhouse in some of the audio areas. Working at Clubhouse has been kind of interesting in that, sort of being an audio first app, it kind of forces like in some ways like limitations force like innovation. And one of the things I kind of encountered was, if you're in a room and audio is all sort of feeling to come from the same place, meeting audio can feel kind of fun. You can listen to a music recording and it feels like you're practically in the same room with the performers. But if you're listening to, Zoom call, it can sometimes feel like AM radio. So I looked into the literature, and one of the things I realized is that if you have to tell people's voices apart just by their sound, that can be a pretty draining task because it actually requires the process of attention. Now, attention is kind of a conscious thing and is sort of an invisible tax on your mental energy. Now, instead, when voices come from different positions, they can be disambiguated with much less cognitive effort, which kind of removes that invisible tax, reduces fatigue. So in Clubhouse rooms, we use tech called HRTF, head-related transfer function, to sort of acoustically position other participants in the room in an arc around you. It's kind of like stereo, but it's actually, it creates this much richer illusion because it's actually in not just a line, it's actually an arc. And I feel like it makes conversations feel much, much more natural. And if somebody tells a joke and you hear this laughter suddenly coming from everywhere, it really makes for an immersive experience. Now, another thing that we have seen people do in Clubhouse and other sort of real-time social apps is actually perform music. And at Clubhouse, we wanted to make sure that we could make musicians sound their best. They go to great lengths sometimes to wire their instrument through a soundboard and apply effects and then pipe it into the app. But the resulting audio in the first iteration would often come out pretty lo-fi after going through all the typical processing and the WebRTC voice stack. So we tuned that out and took advantage of some of the things that have been added in recent phone OSs and phone versions to support stereo capture. And the result was the ability to actually send, unprocessed stereo audio all the way from the musician, to all the way straight through to their audience, all over WebRTC. And this really made for a much, much improved, listening experience on Clubhouse, and really a great ability for someone who wanted to be a music creator on like a real-time social platform. The other thing that we were able to accomplish was the ability to have real-time jamming, where people could actually play music together, playing instruments in different locations. And your service needs to have very low latency for this to be possible. But the fact that it's even possible at all is kind of amazing. And one of the things that especially works well is if one person plays rhythm and other people are sort of take turns soloing over that rhythm, it really works out extremely well, even if your latency isn't perfect. But there's still a lot of work that can be done to improve latency to make that experience even better. But again, it's a type of interaction, people playing together at a distance, that maybe nobody would have thought was possible before. Another place where I suddenly find that there's a lot of things that could be done is just in the area of understanding the content that's happening in RTC. Speech recognition has gotten incredibly good over the past few years. And it's just the notion of having captions in meetings or rooms is an incredibly useful feature. It's not just for accessibility purposes. It can also be just for you weren't paying attention. You missed a word. You just wanted to see what was said. Or you enter into a room late and you want to scroll back and see what was said before. There's really just scratching the surface here. Imagine just being able to go to a meeting and at the end get a summary of what was discussed and any action items without any effort on your part. I think there's a lot more to be done in this space. I mentioned some other possibilities, being able to sort of detect the types of music that are being played, find music that you're particularly interested that's being performed live, better ways of reporting abuse and avoiding, problematic scenarios. I think that the more that we're able to understand what's this type of content we haven't been able to understand in the past, we can do really, really rich things. Finally, there's been a lot of other great progress in another domain of AI-based noise reduction. Now we have technology that's sophisticated enough so that in addition to removing background noise, all sorts of transient sounds, dogs barking, leaf blowers, can now be filtered out in addition. This really makes for a much better sort of large meeting interaction where you don't have to have distracting sounds coming from other participants, but we still have to sort of figure out what to do about the mute button. Pretty much every meeting that people are involved in, there's always somebody where it's like, we can't hear you, or like, could you please mute? And it's still way too easy to forget to hit that button. So there's got to be a better way here. I think if somebody comes up with a solution, that by itself could be a billion-dollar business. Okay, so we talked about audio, but one of the other key things for these real-time social apps is, again, they're kind of all focused around group communication. But it turns out actually making that group communication can occur can be pretty challenging. When we first introduced WebRTC, we found that a lot of people ran into challenges with not building the app, but actually deploying signaling and turn servers that are needed to actually make the app work well. It turns out that when you want to release SFU servers for group communication, that's actually more complicated than using turn servers. You need more servers, first of all, and the server actually itself needs to be a lot smarter. Then if you want to support public rooms, where there could be thousands of users in the same room, things get much, much more complicated. You can't fit everyone on the same SFU server, and the typical approach is to scale up on multiple servers, run into real challenges with load balancing in these large room cases. And it's not just CPU and bandwidth that you have to worry about, but there's also how many copies you're making of packets and your mem copies and memory bandwidth. There are a lot of great open source SFU projects, but unfortunately there's not a great turnkey solution if you want this kind of scale. Now, this is where platform offerings like those supplied by Agora or Twilio can really distinguish themselves. They basically have the thing where you just put in an API key and call some APIs, and now you have thousands of people sort of all together in like a single room. Now, the Agora team's been able to do this. I can tell that they've been working very closely, paying attention to what's happening in WebRTC. It turns out that 25% of the entries in the WebRTC watch list are actually from Agora users. When I take a step back, I wonder if real-time social apps, what if they didn't need to build their own conferencing? And Apple's taken an interesting approach with something they developed called SharePlay. And the basic idea there is that they'll take care of the communication aspects, and then SharePlay apps can focus on their individual use cases. They've even built out a web API for this called Media Session Coordinator. And using this, you can have something where both mobile and web users can watch a video together and have group communication through a FaceTime call, and their actual video position, their playhead, will be synchronized at the same point. So if someone pauses, it pauses for everybody else, and everyone experiences the same jump scares at the same time. So Apple's platform is limited to FaceTime users right now, but I wonder if they're onto something. If we built a layer on top of real-time communication, it would be really interesting to see like an open platform for real-time social apps where they didn't have to go and build all their sort of SFU and RTC infrastructure themselves. One way or another, someone has to build SFUs and RTC infrastructure, and I think there might be easier ways that we could do that. One of the biggest challenges with kind of deploying RTC infrastructure is just that it's kind of a different world from the HTTP infrastructure that's supported really well by most of the big cloud providers. If you want to build a cloud HTTP application, there's lots of stuff you can get almost for free, where it's load balancing, authentication, elastic scaling, all sorts of things, health checking, where you say, I'm going to use this service, and it's largely done for you by the cloud provider. Unfortunately, if you're building RTC apps, you're likely dealing with like raw VMs and IP host support. Basically building it all by hand. So yeah, I try to wonder, like, is there some way we can do better here? And I think the way that this would probably most likely happen would be some way to bring together HTTP and WebRTC worlds. So you can still get the high quality, low latency experience that WebRTC provides, but at the same time benefit from all this HTTP architecture that I talked about that's been built out over the past decade. Now, there's a lot of interest in this for obvious reasons, and a new effort called MOC is spinning up at the IETF. It's not the first time we've tried to solve the problem of bringing these worlds together, but some of the technologies are a lot more mature now, like Quick, for example. The core idea here is overall pretty simple. If we already have a quick connection that we're using for our RPCs, can we just send our media data over that too? But as usual, the devil's in the details. Like, how should we negotiate the actual configuration of what media we're going to send, and how should we send the media? Should it be datagrams, should it be streams, and how should it be packetized? And whose congestion controller should we use? The one that WebRTC likes to use, or Quick's own built-in congestion controller? There's actually a lot of things to figure out. There's some different proposals for what we should do, but they basically right now fall into two categories. We either start with Dash or HMLS and make it support like lossy transfer, or we start with like RTP and WebRTC and we change how the transport is done. Both of these are pretty interesting approaches, and I'm pretty optimistic we'll be able to figure out a solution here. The main thing overall, though, is that whatever we end up with needs to have real technical benefits and not just have better aesthetics. That being said, I feel like there's some pretty obvious wins we would be able to get if we did a good job here. You can send signaling and media over an existing quick connection. No additional media setup RTTs, and we can retain the benefits of using a UDP-based protocol. Head-of-line blocking, that sort of thing. But then also gain these benefits that I mentioned of looking like HTTP. So, fingers crossed. And this is something that I expect to have a lot more momentum in the coming months. Anyway, that's kind of my view on real-time social apps and RTC3. I think it's a great time to be an RTC developer. In many ways, the success we've already seen for this generation of RTC is a result of the effort that's gone into the previous generations over the past 20 years. I've just scratched the surface on some of these possible future directions for real-time social apps. So there's a ton to be excited about. And thanks for watching.